Hello, this is Lune, and this is devlog number 2 of LuneOS. I realized today, just now, that I actually passed the 24-hour mark. I was supposed to make a video at the 24-hour mark, and then I forgot. So here we are. Um, as you can see, I've been coding a lot more in assembly. It's now my top language, I'm pretty sure. Yeah, it's my top language with C. And just doing makefiles, oh my god, this has been terrible. Um, with I believe, I actually don't know what this would be. Um, but Java, which is apparently supposed to be my language, my main language, is like way below. Um, yeah, I mean, this is like obvious just because I swapped to Linux really early into the project. Um, Basically, all this was working on LuneOS. Devlog number 1 happens, I think, around right here, and then this is really just debugging. I mean, it's really a shame. Oh, I guess that's why I haven't really been doing these devlogs, just because I've been working on debugging a lot. Basically, the what would happen was LuneOS would enter into a boot loop, transitioning between stage 1 and stage 2 of the bootloader, meaning that it would never actually be able to reach like C, just because it's never being able to enter 32-bit protected mode. So it would just crash, just because you can't run cross compiler like GCC on 16-bit real mode. So very interesting stuff. I have my Git repo up right here. I've been working on this for a while now, you can see, but really exciting. Definitely the main difference is here. There's a lot of things that I realized were wrong, especially initializing 32-bit protected mode. The stack would literally just kill itself. That's S1. Um, Scrolling down here, I don't think any of this is different. No, that's okay. And also the fat. While we were initializing um, the the FAT12 file system, a lot of this wasn't actually built for GCC. So it would kind of just like crash. By fat, I mean like everything related to memory. That includes everything with a disk. Um, very interesting stuff. This used to be very different, as well as the print function in stdio.c in stage 2. This used to be very different because while we were still in 16-bit real mode, we were able to directly use interrupt 16H with the BIOS and just make like a loop in assembly. I believe that's what I had for BIOS helpers down here somewhere. BIOS helpers. Yes, literally just using interrupt 16H. So this was my old print function. But to implement like different arguments and be able to print numbers and special characters and new lines um, in GTC, just because we are in 32-bit mode, sorry. So we have access to a lot more stuff. Very exciting. Obviously the code's gonna be a lot bigger, but basically this first starts off by organizing the type of data it is, and then prints it to the screen directly to this video. Yeah, to this address, which is the screen. So now we're able to do colors. It's awesome. Very, very fun stuff. Yeah, very fun stuff. I'm very excited. Yeah, this is amazing.